kids, welcome to Introduction to Circuits. Put that title on your page and put the date on top.
Here we go.
Okay, all circuits must have three parts. They will have an energy source, so they're going to have something that actually provides the electrical energy for the circuit, such as a battery, an outlet, or a generator.
Then you have to have a resistor. So a resistor is what actually then utilizes that energy. So it can be a bulb, a motor, fan, TV, anything that takes in that energy and then does something with it.
And then finally, you need wires to connect it all together. So wires just connect the resistor to the energy source and vice versa. There might be other parts shoved into a circuit sometimes, but they're not required. These are the three required pieces. So you will see us using switches occasionally, like to power on and off the circuit, but that's not necessary. You can have a circuit without it.
Okay, so there's some universal symbols that are used when you draw a circuit, so you need to get familiar with these. So this would be a good thing to get down in your notebook. So you see up at the top there, there's a wire, which is just represented by a straight line, okay? Have to have that. There's also a switch. Switch isn't mandatory to have in a circuit, but it's what controls the flow, so you can turn things on and off. Your energy source is represented with two lines, one being a positive side, one being a negative sign, which if you ever look at batteries, you'll notice that one end of the battery is a plus sign and one end of the battery is a negative sign, okay? And then you have your resistor. Your resistor might also be represented with a circle with an X in it. So either one of those represents the same thing. Keep in mind that energy sources and resistors, there's more than one type of those. So those symbols are universal for any type. So that symbol will be used for a battery, a generator. The resistor symbol will be used whether it's a light bulb, a fan, a motor. So those are just universal symbols.
Very good. Draw this in your notebook. Draw that whole section with the symbols because we do expect you to know those and use those. And then if you wish to draw the real life looking picture, you can, but that's not necessary.
You need to be familiar with those symbols because you'll see those on tests and formatives.
Yep. And we do use both light bulbs, like resistor symbols. And they're not necessarily light bulbs, but we do draw the one with the X because that's easier for us to do in the computer. But often you will see the squiggly line one too. Just depends where we get our graphics from. Okay, now we need to talk about the two types of circuits. I know that you did electricity if you were in Parkway, probably 4th or 5th grade. So some of this is kind of repeating what you learned, but we'll just go a little deeper than what you did back then. So we're going to go over series and then we'll go over parallel.
You want to take notes on both.
Yep. Okay, series circuit. In a series circuit, there's only one path for the electricity to take. So if you look at that circuit on the screen, the electricity will leave the battery and it's going to go through each light bulb one at a time. And it has to go through the first light bulb in order to reach the second light bulb. So if the first light bulb is broken, the electricity can't flow anymore.
So then the other light bulbs won't light up.
Exactly. So let's look at some advantages and disadvantages up here. And let me try to write. Now, when I'm writing, I can't see where my cursor is, so it's really hard. Getting closer. There we go. So a good thing about this thing,
it doesn't take as many materials.
So less
So it's not
materials.
Yep. So it's not as expensive to build because you just need a couple wires to connect all your bulbs or all your resistors to an energy source.
So less materials means less expensive.
Yep. Another advantage is they're easier to build.
That is a nice advantage. And you'll have plenty of opportunity to build these, and you'll see how easy they are to build.
Yep.
Now, so it's easy to build because it's just connected in one like big circle. Oops, I really can't see where I am. Here's a disadvantage here. If this light bulb here got broke, the electricity can't flow anymore. So a major disadvantage is when one is out, all are out. Writing over our faces now.
Yep. So if you had, for some reason, your phone and your TV in one series circuit, if your phone goes out, then you can't watch your TV either. So that's a major bummer.
Right. Christmas lights or holiday lights used to be wired with series circuits, and if one bulb went out, the whole strand went out. Now they wire a little bit more complicated, and only a section now goes out. But you could tell where that section's like wired in series because the whole section goes out together.
So in order to get that section working again, you have to find the bulb that's out.
Which
so you
one
got
is
to check
broken?
every bulb.
Another disadvantage is that the bulbs, if they're bulbs or the resistors, they get dimmer as you add more. As you add more. And if you're not using bulbs, maybe you're using like fans. If you have 2 fans wired in series, the fans will go slower and slower as you keep on adding more fans. If you're adding light bulbs, which you will be doing later in this power standard, when you add 1 bulb, you're fine. You add a second bulb, now they're sharing that electricity. It has to go through the first to get to the second, right? So it's going to get a little dimmer. When you add a third one, you're increasing the resistance there, and it's just going to get dimmer again.
So think of a series circuit like a 1-lane highway. The more cars you put on the 1-lane highway, the harder it is to move, so traffic slows down.
That makes sense. Oh wait, if you have any questions, come find us. We're going to continue on with parallel circuits. Oh, here's another picture. Did I make them draw it yet?
I believe you did, but if you've not done that yet, you need to draw a series circuit.
Yeah, draw it both ways, the one with the bulbs and the one with the symbols.
And label it series circuit, and I would label your parts. So label the circles with the X's in it as resistors, so that you get familiar with those words.
And that skinny line and the fat short line, that's your energy source. Oh wait, parallel circuits.
So parallel circuits are a little bit different as that they have more than one path that the electric current can take to power things. So just like when we talked about series circuit being like a 1-lane highway, think of parallel circuits like a 4-lane highway. There's more than one lane that the cars can travel down.
So the electricity can take this blue path, and I'm trying to make another path, but I really can't see. Where's the cursor at?
There you go.
Gosh, these computers.
You're all the way over on this side. There you go.
It won't let me write. Okay, so some electrons are going to go on this first path. Some electrons are going to go down the second path. Some electrons are going to go down the third path. And you can go on the first path, and it's going to go back to the battery, because that's what electrons do. They leave the battery, and they need to return to the battery. So some electrons are going to go skip the first path and say, hey, I'm going to go to the second path. And then some electrons are going to go all the way to the third path, and they're going to return.
And the great thing about a parallel circuit is if that first resistor is out, so something's wrong with it, the electrons still have other pathways to get to the back second and third resistor, so those will stay on even though the first one isn't working.
And if the third one, see now I can see it. If the third one's broken, then all the electrons are going to take this middle path.
Yep.
Remember, the wires are a one-way street, so they cannot go down. It's just a one-way street. Like if you're downtown St. Louis, there's a lot of one-way streets. Your car can only go a certain direction. The wires in all circuits are the same way, so you can't get electrons to flow opposite.
Yep.
Okay, so
Here's your picture of parallel circuits. Make sure you draw it.
Yep, that's what I was going to
And
say.
label it.
So pause the video and draw that. Advantages and disadvantages. Oh, I lost the cursor again. That's weird.
Okay, so your advantages are that it's more expensive to build because...
Isn't that a disadvantage?
Just kidding. Right, we're on advantages. An advantage is that if one bulb goes out, the other ones stay on. These were switched last time. The series circuit disadvantage was on top.
If one goes out, all stay on. Another advantage, the brightness is not affected. So brightness remains the same. So if you, in theory, with this circuit on the side, there's 2 bulbs. If we add 10 bulbs, they're going to be the same brightness. If we add 20 bulbs, they're going to be the same brightness. What happens though, because you're like, seriously, how does that work? One of the disadvantages, it will drain your battery faster, or use more energy if you're using an outlet. Drain battery faster.
And then another disadvantage is it's more expensive to build because in order to create those other pathways, you have to have more wire.
So more parts. And it's more difficult to build.
Yep.
Okay, So write these advantages and disadvantages down, and you will build some parallel circuits in the next couple activities. So you'll kind of see how that works with the advantages and disadvantages. Okay, so here's something that's, most circuits aren't parallel or series. They're actually a combination. And we've heard these called a couple different ways, so I put both of them up there. They're either complex circuits because they're complicated or complex. Sometimes they call them compound, like a compound word, dog, house, compound circuit has series and parallel. So use both. And basically the definition is some circuits include elements of both, parallel and series circuits. Mm-hmm. Did I put a picture on here or did I not?
I don't think you did.
Yep.
Oh, yeah, you did.
I have two there. I remember that now. So here's an example. You can see that D and C are in series. So if D is out, C will not work. Technically, if D is out, nothing will work because everything has to go through D to move on. But look at A and B. Light bulb A and B are in parallel with each other. So if light bulb A is out, the electrons still can make it back to the battery. They'll just go from D to C through B back to the battery. So the circuit will still work.
And if B is out, they can go through D, C to A.
Yep. I have another one, I believe. There you go. Here's another compound circuit where you have the back two, which aren't labeled. Those back two are in parallel. And then you get that one guy by himself that's kind of like in series. So that one guy up there, he has to work all times or the whole circuit is shot because he's a direct path back to the battery. But the other guys, one of them only has to work. And here's what I always tell my kids. Like if I get confused, because we will test you, like, hey, what happens if this bulb is out? What my suggestion is, pretend you're an electron. Use your finger and pretend your finger is an electron. Leave the battery. If you can find a path back to the battery with your finger, then you are a circuit that works. Anything that your finger followed will light up. So let me see if I can get the airliner to cooperate. Here we go. Leave the battery. Bing, ding, he works. Can't go that way. So I've got to start over. Leave the battery. Okay, he's going to work too. I got back to the battery. So those two that I passed will work.
And one thing else to point out here, if you look down where your energy source is, do you see how there's two short lines and two long lines? That just means that there's more than one energy source there. So maybe this is a circuit that we're using two batteries on.
Which we'll do often.
Yeah.
We don't make you draw all the batteries. You can.
But just in case you see it, you know that why that looks different than maybe what you've learned in the past.
Okay, kids. A lot of this will make a lot more sense once you start building some circuits.
And this may be a good one to watch more than once. So feel free to rewind us, watch it again, take your notes, come talk to us if you need to.
Sounds good.
See ya.
Later.